Hello, welcome to this video in which we will see how network automation can help with network configuration management. We will focus on the VXLAN EVPN technology. It's an extremely cool thing, completely based on standards with which you can implement a very scalable multi-tenant network, but as you can see there is a certain complexity, a certain complex config that needs to be maintained in sync across multiple switches. In order to solve that, I have developed something I consider to be pretty cool, which is a shell with which you can automate, you can create these objects across all your switches and you can delete them as well. I'm using the CMD2 shell module for Python that allows you to build really quickly some shell. Here I'm loading the config from my lab. As you will see now, I have two leaves and one spine. All config is primarily done on the leaves. And now we can start seeing what's configured here. We can have a look whether there are any VLANs configured. As you can see, there's something, but not really much. We can have a look. You can filter this as well. For example, if you are interested only in what's configured on a certain switch, you could filter this. There you go. And we can have a look as well at the tenants that have been configured. As you can see, there's none. So the switches have the initial VXLAN EVPN configuration, but nothing more. So no network traffic is going on. In order to verify that, we can log into one of these leaves and have a look at what's going on there. So here with this command we can see there is not really a lot of VRFs. These are the default VRFs. Looking at the VLANs, we can use this command to see which VLANs have been configured for VXLAN. There's only one that doesn't have anything to do with our test. We can have a look at additional pieces of configuration that would contain details of tenants and tenant networks, and they are empty. They have the basis configuration for VXLAN, nothing more. So now we can start creating objects. First thing we need to create is a tenant. We have a look at the help, and here I will use exactly the example provided in the help. So a tenant with some parameters. For example, it's going to be configured in the BGP 100 process that has been already created in the leaves. So that was easy. Let's have a look. Yeah, so we see this tenant has been created successfully on both leaves. And now we can verify whether something is happening here. So there's an additional VLAN with an additional VXLAN VNID that will be used for the layer 3 communication inside of this tenant. We can see that there's an additional command that has been included in the VXLAN interface here, which is exactly that one. And we can see that there's an additional VRF, this tenant 1. Before there was only 2 VRFs default in management, now we have the tenant 1. Right, now we have the basic framework where we can create networks, subnets, VLANs if you will. So let's have a look again. Yeah, not a lot of VLANs. There's this new 3900 that was created for layer 3 communication inside of tenant 1, but now let's create actual networks for our customers. So let's take the example out of the help. Let's modify it a little bit and create 2 VLANs. It will be the 101 and the 102. I will change the multicast addresses so that they are easy to remember to 101. I will change the VNI, the VLAN description, and the VLAN ID, of course. So there you go. And now we can create another one. We will create VLAN 102. We change a couple of things, for example, IP address, VNI, description, and VLAN ID. We created, and now we will have a look whether, at the tool whether those VLANs were actually created. Yeah, they are there. IP address is there. As you can see, the IP address is exactly the same on both leaves. This is a feature of the VXLAN EVPN fabric. You can have with the Anycast gateway feature, you can have the same gateway all in all the leaves. You can see here the VLANs were created, the VNI was assigned. You have these two additional SVIs or layer 3 interfaces. And yeah, we can have a look at additional parameters. We can go as well to the second leaf quickly to see whether the configuration was created there as well. So let's quickly jump into the Nexus 2. Oh, I always make this mistake. Password, and we can run the same controls here. So the tenant 1 VRF exists. The two layer 3 interfaces for customer networks exist here with the same default gateway as in the first leaf. So this is standard VXLAN EVPN configuration, nothing magical. The only thing interesting is that all this was automated, and you saw how easily these things were created. Okay, as you can see, we don't see any peers yet. That's because there's no traffic that has triggered the exchange of information. So in order to do that, let's have a look at two ports where I have connected some servers. Here in the leaf 1, I have one server on VLAN 101, and in the second leaf, in the leaf 2, I have another server in VLAN 102. Where is it? There you go. Connected. That's good. Now we can start generating some traffic. For example, let's try to ping this second server from here. So the IP address I configured in the server is the 102.102. Easy to remember. First ping doesn't work. The second one goes. The first ping got lost in the ARP request. Now if we go back to the first leaf should have learned now this IP address. And by learning this IP address, this EVPN adjacency was established. The second one doesn't see anything yet because the first leaf didn't generate traffic. So the first leaf now knows not only the locally connected machines, but as well this machine that is connected to the second leaf that learned over BGP. So you can see all of these pieces that we created automatically are working together very nicely. We can do exactly the same here. We generate some traffic to the local server so that we learn it and then we advertise it to the second leaf. Now we learned as well this address locally. That's what HMM stands for. Don't ask me anything else there. HMM, for me, it's locally learned. Now we can see the peering adjacency has been established because leaf 1 had something to advertise, and here in leaf 2 I'm in exactly the same MAC and IP addresses. Note that I'm advertising MAC and IP addresses with BGP. And these leaves are doing not only switching but routing. So if we SSH to this server, connect to leaf 2, it was the 102 again, remember, and we ping the 101 from here. It's a different subnet. We will do that over this VXLAN fabric, thanks to this default gateway functionality. So this is standard. Oh yeah, and the ARP, the MAC address that we are saying is a MAC address that has been configured in leaf 2. This 222 is the MAC address in leaf 2. In leaf 1 I have a 111. Very original. Yeah, so I can ping the default gateway, I can ping the other station, and this has been done thanks to the VXLAN routing functionality here. So this is standard VXLAN EVPN behavior. We created it very easily, and now we come to another problem that happens in multiple data centers: how to get rid of this config if I don't need it anymore. So it's as easy as creating it, even easier actually, because you have to give fewer parameters. So we delete this VLAN. By the way, one possible enhancement would be eliminating the need for entering so many parameters. Actually, that would be possible. So we have removed 101, 102. These have been removed from both switches. Now we can remove the tenant. We delete the tenant. I need some help here because I need to give these parameters. We use the default ones from the help, so we can stick to those. Remove the tenants. That's it. So our config is clean again. If we go back to the switches, we will see that all that was created, all that building that was created in order to configure VXLAN and EVPN and BGP and all that, this has been removed. So we have all the beauty of VXLAN and very easy to use thanks to automation. So you see these VNIs disappeared from the different configuration sections. No VRFs anymore. We cleaned up everything here. So I hope you liked this video. Again, this is an example of how to use NXAPI to automate network configuration in Nexus. Thanks for watching and hope you like it.